Hello everyone, we are live now once again, just thinking about what is this technology all about. Let me just give you a quick brief intro. So I'll be doing the meager version of all these technologies and things like that about the cybersecurity. Have the course material ready. Right now it's ready in my room. Like it's like a 3 day or a 4 day boot camp. I don't know how much, but yeah, no, this big amount of material is ready, people. So it's not about that. It's all about getting the right approach for what is going to happen, what is not going to happen, and things like that. So what I did was I didn't give a damn about anything. So what I thought was someday, jab bhi mood aa jaye, I'll just give some technologies. I'll just say on something that I've learned over the course of time in cyberspace, security space or the cyberspace. So what I thought was just leave all these. Let's just go on. Let's just make some good videos. So that's where I started. So let me just go on, people. So this is what Rambleed technology, Rowhammer, and the hardware-based approach, and all these kind of nonsense that we'll be talking right now. So Rowhammer is something which is always experienced by somebody called as RAM in your compute system. So it's not CPU which makes that change, it's the capacitor in it with charges and the discharges over the course of time causing this. So Reno hammer is basically an not that complex of an explanation. I would just say it in simple terms. It's like it's just an overload for the RAM and its mechanism where there's a transistor, there's a capacitor where it will be charging and the capacitor discharges and there will be a refresh command which will always be sent, and this causes the row hammers to happen over the course of time, and it's very, very, very useless. So what you want to do is you just have to go there, type in Rambleed on your Google search. What you are going to get is this freaking paper. And this paper is something which is like the gold standard for explanation that I also used. So now it just pops out to this one, and this technology is something like you will never get to know what is really happening reading bits of the memory without accessing them. You just have some malware, you just have some function, you have some API calls through a RAM, done with it. You are going to just have this RAM lead attack at every given point. So RAM lead reads bits in memory without accessing them. So this is the paper that I was talking about, and it's an amazing paper. Do read it, check it out from the same link. And this is the 60 RAM, where basically it's a 60s RAM, so serial random access memory and all these kind of nonsense. So don't take too much complexity. There's a read bit, write bit, and a hold bit, and all these functionalities have been kept here so that you don't get that meager understanding of it. So every time there's a read command, there's a write command, and this four transistor state will be same until and unless you change something through this read and write commands and things like that. So these are the four transistor which holds that memory state, either one or either zero. There are a lot of philosophies on VLSI and things like that. Do check it out, it's required. And I would just suggest a book called as google.com. Oh, it's all right. Neil H. West. Yeah, it came in. Neil H. Westy. And this is the book where you get a complete understanding of what this technology is all about and just go and learn it there. So, got to know it. So, this is what your 40 SRAM looks like. Simple, easy, neat, and clean. It's just the switches. It's still the NPN transistor. It's not PNP where it's not going inside the transistor. This arrow should never go inside the transistor. So over the course of time, what it does is there's a read bit, write bit, and all these things. So there'll be data which will be flowing in and out, and there'll be commands which will be controlling how the transistor has to move, the commands and things like that. So spoiler, yet there is a new way in which an attack can happen. So we thought, okay, RAM was spoiled, but there is something called as CPU attacks, which can really happen. So if you want to know more insights about the hardware and the things like that, I would just suggest you all to go for Onur Onurmutlu Mutlus lectures, and it's an amazing series. Like, you guys have to see this entire scenery. Like, it's like gold standard for all the lectures that I have seen. Like, it's the best lectures that you can ever see. Okay, we are live now, and we will just go back here and think about it. So Intel CPU spoiled, and all these news have been popped up over the course of time, and there are papers for it, so do check it out. And I will also be making some reviews of some papers. So yeah, these are the amount of ports which are there in your system. Your RAM is an entire set of hardware which allocates memories and ports and all these things. Your CPU has ports, your motherboard has ports. In fact, your entire Docker system runs on the port basis, the port based system. And basically what you think of, like, you don't think of that underlying complexities of like ports and okay, it's just the thing, but it's required. So I think probably John Willis's 7 diseases of the development and the DevOps and all these kind of things, they also focus on security. He's also the creator of the word called as DevSecOps, and trust me, he's an amazing guy. A simple introduction. What is this all about? This is a Wireshark application which is just reading in the data. You can use it for packet sniffing. Packet sniffing is amazing through Wireshark, and Wireshark is an amazing tool for it. And like you won't believe the amount of way in which this thing is working. It's an amazing tool. So you can see some of the Wi-Fi things. There are adapters which are working. There is no Ethernet now. So npcap is basically a program which basically says about all the installations and all the things. So it's basically an nmap where application also uses the same thing, where port scanners and everything comes into the picture. So there's a meltdown which is also a vulnerability which is also very, very crucial. Trust me, it's so crucial that even every time when we make some decision, it's going to be like, hey, what are you doing? So meltdown is one of the vulnerabilities which was there on the Intel x86 architecture. So you guys can have to see it. So OpenSSL is basically an module which library which is used for secure communication over the course of time, and it's basically used for your websites and things like that. Your SSL certificates, what it is. So OpenSSL is also one of the standards, an open source standard for it. So why I showed you this, it's because low level virtual machines are still used in your Android development, and I do a little bit of Flutter, not too much of Flutter, but yeah, a little bit of Flutter. So yeah, when you think of emulators and things like that, this is how things are here. Okay, I should actually show you guys the RAMs, right? Yeah, wait, I'll show you guys the RAM, random access memory. You won't believe the size of the compute that you can see here. I think I'll go back to this one. So I'll remove this. So this is the RAM, which is 2 gigs. Yep. These two are 8 gig sticks. 8 gigs. It's crucial. So together there are 16 gigs of memory. So the form factor of this and this. There are different form factors for every technology that you're working. So keep in mind, your aim is to always reduce the way in which this technology is getting built. So your phones today have 12 gigs of RAM, 16 gigs of RAM. Probably there will be terabytes of RAM installed onto your system, and the technology shrinks to something like 3 nanometers, 7 nanometers. Don't know, man. We need to check it. So let's just go back, present my screen. So rowhammer is a very simple mechanism where we do a lot of flashing, we do a lot of decision making for the RAM to store the bits and the bytes. And what happens is that capacitor, which is just so tired, will always ask for that refresh command. I need some energy to store some data. So this is where things move on and they start draining in, and that's where your request pops up and says that, hey, it still works with the law of conservation of the energy. Energy can neither be created nor destroyed, but can be changed from one form of energy to the other. So it will go out as an heat, loss of electrons, and things like that. So to just give you a brief, simple introduction, this is your Cmos circuitry, which is there, and this has all the things or layouts, and this is just a layout which I took it from the internet. So yeah, we had VLSI lab, but I never felt it that interesting. So let's just go back and see what is the CPU and GPU is all about. NVIDIA's video on the CPU and the GPU is an amazing explanation. Just go back, check it out. You guys will pop out with something new as a learning. So this is actually a technology which is basically for the Rambleed JS technology. It was amazing because this is where the root privileges for the web apps and all the vulnerabilities were being talked. And trust me, I think this is one of the places where you get that knowledge of what this rowhammer JS and row hammering is all about. And YouTube was down for a while and everything went on like for a while. It happens for a while. But you know every application has its own perks, pros and the cons of it. So you can really go back and look at what's the debug information and things like that. And the stats for the nerd is something which I love, so go back and check it out. Just right click on the video, you will get it. So I just want to say you guys one thing. This is something where these are all my friends, so yeah, don't worry about them. So when you type something, it just doesn't go there. That's where the schema comes into the picture. The RAM is not storing any of the data sets or any information that you are thinking about. So even if I press and inspect here, it's not still there. It's still not there because it's not in the schema. As soon as it gets inside the schema, it just goes in. So code for the making, I think it's basically the same old cryptographic techniques, same old techniques, but I hope one day row hammer gets solved in all our systems and we will have a fully efficient system for the building. And thank you, folks. That's it. As theory, let's just touch on to some of the things, the stats for the nerds and things like that. You know, I think this is one of the ways in which you can really understand what this technology is. DRAM, rowhammer, spoiler, Rambleed, TRSS pass. Trust pass is basically one of the vulnerabilities. If you guys go to Google, type in trust pass. Where is this trust pass? So yes, so you can automatically discover the rowhammer fuzzes and all these things. So trespass is basically one of the applications. Still C, Python, Shell, all these files are still used. So don't worry. It's still not that complicated over the course of time. So research papers are there. So trespass definition. So yes, I would just say I'll go for the definition of it. Trespass is basically the way in which you won't get it. This is where people don't get that absolute definition of what it is. So what I do is I just go on with the paper. So DRAM refresh, all these contents are gold. I'm not joking. If you want to really learn, and just go on with it. So CVE 2001 200, I think probably the patent number or things like that. So CVE. So this is where they are coming out with some standards and all the things that are there out there. So spoiler, Rambleed, half double, these are all some of the hardware vulnerabilities that you can witness in the real time. It's happening actually. So let's just go to this paper. Actually, this is actually the slideshow of how this Rambleed and all these green memory solution. Basically, they are talking about all the things that are really required. I got it from the references here. So you guys can go here and check the slides out. It's amazing. Actually, I would just drop it in the comment section. If you guys can find it in the later part, just go ahead with it. So this is the one that I popped in. So let's just go to this blog. Actually, this blog is actually a very overview introduction to all this kind of attacks and how they are working, some Linux stuff and the OS stuff. So you guys have to check this out actually. And throw hammer is actually one of the attacks, and basically these are so freaking awesome. Just go back, read this paper, amazing paper. Just go back, read it. So throw hammer is still here. ECC polite, ECC memory vulnerabilities to row hammer attacks. After all, it's basically, it's basically commands which are just elastic. ECC memory elastic cloud complete. So error correction code memory. I was just joking there. So all these blocks and error correction codes, and yeah, when I showed you about this code for code in the making, all these cryptography and all the things pop up, and this is one of the things where I would just say you guys have to look back and look at these VLSI layouts. And actually I would just say any book on VLSI would be great for introduction of it. So, and meanwhile, if you think like, okay, I would have had learned something, there are some papers which say telehammer, and there's nethammer attack was also there. So it's all similar. So you guys have to just go back, look at what all these attacks all about. And nethammer is there, all these things, amazing, these attacks and all the vulnerabilities that has been analyzed. Just go back and think about it. So this was what I was talking about, the Rambleed. Read the papers, cite it. You can cite it if you are doing something on computer architecture. So the exploit attack is slides where row refreshes and they just trespass in terms of like the code. So bits of code can make a lot of changes. That's where trespass exploits comes into the picture. Basically these are not vulnerabilities, these are attacks that you can think about. So trespasses and all these things are so awesome. Just go back and just look at all these papers and things like that. I think I have to show you this is an amazing paper actually. This paper is so awesome. I think it's basically the same way in your queue stack and everything work, but the way in which the attack happens, it's derived mathematically, and I love it. So you guys have to see it, and it's so freaking awesome. So CMU, Carnegie Mellon University, has also given out a paper on these, and I would love to talk about this paper. This paper is so awesome, and it's basically just bit flips, all the things that you see in your radar components, like when you go radiation hardened components in any of the space tech platforms and things like that. You guys get to know what is this technology all about. So flipping bits without accessing the memory is basically like you getting to know that there's a pacemaker in somebody's heart, and if I just go and induce electric and magnetic field, it's going to stop, something like that. So over the course of time, security research has also gone in an extensive way that even VLSI scientists know about the software and the hardware that goes behind making. So I think this is my channel. So subscribe to it. Just make sure that you share all these videos, comment down below. And if you have any doubts about all these technologies that I'm talking about, just ping me directly. I'm in all the platforms like LinkedIn, Instagram, Twitter. So just make sure that you guys learn something from there. And I think this paper is from 20 January, February, March, April, May. Yeah, I knew it. It's May. Fifth month, not May. It's 6th month, June. Fine. Let's just see this paper. Do you have a network? No network issues. Revisiting Rowhammer is something which is so common, and these attacks happen every given time, and it has different form factor to the attacks. I'll say you how your capacitors are being shrunken. It's 12 picofarad, or else even less than that. Fermifarad probably tomorrow. But when you think of like parasitic capacitance which is happening in your circuits, parasitic capacitance which is happening in between the layers, I think probably it forms something like very close to like your hardware as an pitch of attack, like exploits are still there but you're not taking care about it. So even if you have the best of the best code, I think Titan 5 rocket should be a best example. Titan 5 disaster. Disaster rocket. I think this was actually the one of the phase in which computation. Actually, this was actually the rocket which was not that well performing, and software had a lot of discrepancies: 16 bit, 32 bit, 64 bits, and things like that, and it didn't really work. Sometimes pounds and kgs become an error. So pounds and kg NASA disaster. No, like some of the companies like Orbiter is a company which measures the orbit and things like that. So they gave it in kilograms or pounds, and these guys did with some other notation, and it didn't standard units, not notation. To be more technical, it's standard units. So yeah, it became a disaster at the end of the day. So block hammer is there. I think ACM protecting enclaves with intra-core slide channel attacks through the physical isolation. All these things pop up, and I think yeah, these are some of the papers that I would say you guys have to read it. So you guys just go back, read it. Blockhammer is something which is so cool. Just make sure that you analyze that every time there's a low cost attack. Like every time when you improve the architecture, there's a low cost attack popping up. So this paper actually says you how it can be a low cost attack, even though you might not know something about hacking or something. How can you still do it? Like gives you a brief introduction to it, but you guys need to learn every damn thing that they have told in this paper if you want to really perform that attack. So this was the paper, and this was the archive thing. So Blockhammer will come again, I think so. No. So trespass basically the target refresh and all these nonsense that we talked about. So every year the paper pops up and it's a new way in which they will be actually saying about it. So it's not still the same. Telehammer, rowhammer, trespass. It's still the same. Sorry, people. It's still the same. Sorry, people. Rambleed. Why did you stop? This is the paper that I was talking about. Yes. Where are you? Trespass. It's not 2020 publication. Hmm. Still that Rowhammer JS and all these kind of. After the still the same paper. Sorry for it, folks. Sorry for it. So the trespass vulnerabilities and all the things. So that's it, folks. Just enjoy your life. Just keep hacking something new. Just make something new. Just enjoy every day. Don't make it a mess, because life is very short, and all the links, all the papers will be in the description below. So don't worry about it. Be chill. Thank you, folks. Thank you so much. Let me just come out with some new sessions, some new topics, and see you then. Bye bye. So if you have any doubts, comment down below.